question for sure. Let's move on to question 17. That just assume that doesn't exist anymore. And for the rest of these, we're kind of just gonna shimmy through them. I had a plan of trying to get through 30 questions today, but that one especially seemed to have eaten a lot of my time. So let's just continue to move on though. A sample of a compound. Oh, I almost forgot my water break. Oops. Try to do one every hour at least. Okay. A sample of a compound containing CO and silver weighed 1.372. So, sample containing CO and silver, okay, weighed 1.372 grams. Alright. On analysis, it was found to contain 0.288 oxygen, well, grams of oxygen, and 0.974 grams of Ag. Okay, molar mass of the compound, so 303.8 grams per mole is the molar mass. Actually, I shouldn't square that because it looks like an answer. Okay, what is the empirical and molecular formula for the compound? Okay, so a lot of information here. The way we solve this actually is that we actually want to figure out ratios, and you're probably thinking, oh yeah, ratios of the grams. No, you want the ratios of the moles actually, but you're so far only given 2 pieces, but because you're given 2, you can kind of tell how many grams of carbon there'll be. So you started out with 1.372, right? You subtract the grams of oxygen, 0.288, and you subtract the grams of silver, okay, 974. Whoops. 1.372. So you only have 0.11 grams of carbon. And now the next step is that you want to convert each of these into its molar mass. Okay, so let's start with carbon. 0.11 grams of carbon. We're going to multiply that by 12.011, because I mean not by its molar mass actually. The better thing is the atomic mass units, because you want to just get the moles of each one. Okay, and there, grams cancel out. Okay, so that's divided by 12.011, 0.0091. Okay, now for the oxygen, 0.288. Just gonna make sure I have the right numbers actually. Yep, 288 and 974. Okay, good. Grams of oxygen. Same thing, 1 mole, 15.999. Why did I not use the double of it? Because we're actually using only the atomic mass units. We can't assume that oxygen comes in pairs or anything, because this is just a molecule. We don't know the constitution. Okay, so that's 0.288 divided by 15.999, 0.018. Okay, and now for the last one, silver, 0.974 times silver now is actually quite big, 107.87 grams. Okay, 1 mole of silver. So let's actually write down what it is. So it's mole of carbon, mole of oxygen, and 0.974 divided by 107.87 equals 0.009. Okay, 90 mole of silver. Now, you probably start to know something right away, actually. You see that it's the ratios, right? You see the smallest number technically is a silver, but these two right here are quite close to each other. But point being, right, is that you want to get your smallest number and divide everything by your smallest number. So that's divided by 0.0090, 0.0090. So this one would actually just equal 1, okay? So with this, 18 divided by that, it's 1.99, and you kind of just round it to 2 because you want to get the ratios, right, to get your empirical formula. And now for the last one, we want that divided by 1. Okay, so that's equal to 1.01, which you kind of just round to 1. So if we were to write the empirical formula based on these ratios here, actually, starting with the metal, before we go to non-metal, we have AgCO2. This right here is our empirical formula. It's the lowest multiple of it, okay? And the reason why I say the lowest multiple of it, because exactly it's 112. And now you're probably wondering, what are we going to do with this molar mass? You're actually going to find out how many of these AgCO2s fit into that 303 to find out the multiples of AgCO2 there is, okay? So what we actually need to do is now get the mass of each one. So constituents, so Ag, that's 1, Ag, 1, C, 1, I mean not 1, sorry, 2, oh, okay? So it's times, we just have the numbers right there, 107.87 times 12.011 times 15.999, 107.87, 12.011, 31.998, and then we add them together. Okay, plus 107.87, 151.879 is what we get grams per mole. So that means we want to get that 303.8 and divide it by that. So 303.8 divided by 151.879, and we get around 2. So that means our molecular formula is just double of that. And don't be mistaken, you don't want to add the 2 in front. You actually go Ag, because this is our molecular formula, right? You actually want to add them as subscripts. So Ag2, C2O4. This right here is our molecular formula. Okay? So that's what we have right there. So empirical formula, molecular formula is double of it. And you'll see that the math checks out because 303.8 is going to be the molecular formula. We only had 1.372 grams of it. So then because of that, this would be how many of, I guess, each part you would have. Because 1.372 grams of it is 372 divided by 303.8 is 0.04 moles of this. And exactly based on even the numbers we got, well, 0.045 because it's of Ag2, and so I mean of this molecule. I remember for every one of these molecules there's 2 silvers, which is how we got back to now the 0.09 moles. So every math checks out for this. So with that, Let's see, step 1, you're given that they found carbon, which is good, that is correct. They found each moles, okay, and they divided by each other and they rounded. Yep, 2, 1, 1, good. So it's AgCO2, perfect for the empirical formula. And now they figured they only had 151.88, perfect. So there's a ratio of 2. And that means they got Ag2C2O4 for the molecular formula. Perfectly done. This is correct. A lot more streamlined than the previous question, so that's good to see. Now let's move on to question